In this chapter, we are going to discuss wired and wireless media. One of the important elements of a computer network is the communication medium that transmits data across a network. Communication media are divided into two categories, wired and wireless media. In wired media, electrical signal carries data through cables such as telephone lines and fiber optic cables. But in wireless media, various types of electromagnetic waves, such as radio waves, microwaves, infrared, and visible lights, carry data signals. The area of communication medium has had great progress over the past few decades. Nowadays, gigabytes of data can be transmitted through fiber optic, which was like a dream 50 years ago. In this chapter, I'm going to cover topics such as twisted pair cables and their 7 categories, Cat 1 through Cat 7, and then we will go over coaxial cables and fiber optics along with their applications and characteristics. We will also discuss various types of wireless media such as terrestrial microwave, satellite microwave, including low Earth orbit, LEO, middle Earth orbit, MEO, geosynchronous orbit, GEO, and highly elliptical Earth orbit satellites. We will also discuss the cellular system and short-range wireless waves such as Bluetooth and infrared. Twisted pair cable refers to a type of cable which has pairs of single conductor copper wires twisted around each other. It has been classified into Cat 1 through Cat 7. Cat 1, 2, and 4 are rarely found today, but the most common types are Cat 3, which is used in old telephone systems, and Cat 5, which is used in LANs. Twisting and shielding are to protect data signals from interference and noises. In this picture, the structure of a twisted pair cable with 4 pairs of wires is displayed. Each conductor is covered by plastic insulation, and then cables are shielded by an outer cover. The twisting of wires comes from a famous law of physics. An electrical current passing through a wire creates a magnetic field around the wire, and this magnetic field can create an unwanted current in nearby wires. This unwanted current is called crosstalk, which can impact the quality of the data signal. If the two wires run parallel to each other, like part A in this figure, the chance of crosstalk increases. If the two wires cross each other at a perpendicular angle, like part B, the chance of crosstalk decreases. So it is ideal to have cables perpendicular to each other, but as it is impossible, the wires are twisted around each other to minimize the crosstalk. Different layers of shielding also protect data signals from noises such as heat noise that can distort the data signal. In a landline telephone system, crosstalk happens often. For example, when we are talking on the phone, we might hear an indistinct conversation in the background. Twisted pair cable comes in different categories as listed in this table. Cat 1 is a standard telephone wire and has few or no twists. So electromagnetic noise is a common issue with Cat 1. It was created to carry analog voice or data at low speeds like less than 9600 bit per second. Cat 2 cable was used for telephone and low speed LANs. It has more twisting compared to Cat 1, so it is going to produce less noise. Cat 2 can transmit voice and data from 64 kilobit per second to 1.5 megabit per second and runs between 3 to 4 miles. Cat 3 was designed to transmit 10 megabit per second of data over a LAN for distances up to 100 meters. When it travels around 100 meters, the signal loses its amplitude, which is called attenuation. So it has to be amplified if the network size is bigger than 100 meters. So repeater or amplifier is the device that connects various segments of a network by amplifying the signal. Cat4 cable was designed to transmit 20 megabit per second of data for distances up to 100 meters. Cat5 was designed to transmit 100 megabit per second of data for distances up to 100 meters with 100 megahertz frequency. Cat5 has more twists per inch than Cat1 through Cat4 wires, and as such introduces less noise. It can provide full duplex through 4 pairs of wires, 2 pairs for sending and 2 pairs for receiving signals. It is widely used in LANs. But Cat6 was designed to support a data rate of 250 MHz for 100 meters. It has a plastic spacer running down the middle of the cable that separates the twisted pair to reduce electromagnetic noises. That makes Cat6 wire a good choice for 100 meter runs in local area networks with transmission speeds of 250 to 1000 megabit per second. But Cat7 is the most recent addition to the twisted pair family. It is designed to support 600 MHz of bandwidth for 100 meters. The cable is heavily shielded. Each pair of wires is shielded by foil, and the entire cable has a shield as well. Its price is fairly high, roughly $1 per foot.